I will be running first those simple examples that I talked about earlier, and then we'll move into a more complex set applications later on. But first, let's look at some simple examples. So I already have a Mini-NDN setup. As I said, it's a pretty easy. You can just have a box setup, and then you can just run this command, and then as I was saying, this is a bunch of helper options we have. Where you want to install this from. Mine is installed from the source, so I already have that here. So as I was saying, like the first one I showed was this example here, Mini-NDN. Sorry, example MN Pi. So this was the first example I showed. It's a very simple, basic example, which basically runs NLSR and FT on each of the nodes. So that's the first example. So as I said, sudo example ndn Pi, you can use whatever topology you want to use. So for instance, you can use the testbed topology, or you can have your own topology configured inside the script. So for this one, I'm using this default topology. Oh yeah, what I was trying to say is, like, if you don't specify any topology, then it will use the default topology in the system which is already installed, which comes with the Mini-NDN. So, but to make it clear, I would just specify that topology. What happened? Sudo invite type Python. Mini-NDN topology, default topology. Yeah, this is how it runs. Basically, this one is only just starting NFT. Yeah. Now you have the CLI, so you can do a NLSRC status, and then you see this bunch of NLSRC status, like adjacency. So you can also a NLSR NFTC help, like you can run a bunch of this command from here. So basically, you have to type the node name. So this is what I was talking about earlier. Like you can this wrapper already, it's kind of running this command with node name rather than the actual IP address or all this mapping. So this node, and you can see NFTC FIV, you can see the FIV, bunch of interacts thing, ANFTC CS. So this is a content store. You can see all those details about the content store. So the thing is that you can have this same command, same utility running inside your script, so that you can constantly measure these things, like the gas hit and all this stuff. So it's pretty cool. Like you can grab those information already from inside your script. Yeah. So most of all of these commands that you can execute from here, and also can have that from the script. So another one thing that I wanted to show was NLSRC, the prefix advertisement, NLSR. So this is a NLSRC command line utility, and these are the features that is offered by the utility. You can view the LSTV, advertise and withdraw prefixes, and all this stuff. So for instance, if you want to advertise a prefix, NLSRC AD advertise PVC. Yeah. So this is advertised from this node. Now, if you go to B NLSRC status, sorry, I will just do. You should have this already here. So see, now the node B can reach to this prefix. So NLSR already propagated that information to all of the nodes. Now the B can reach to this prefix. So that's how you can advertise the prefix from a node. What else? Yeah. So at this point, when you just running, installing, if you see that we have. We just install. We install after installing a Mini-NDN, and you can just play with NDN pretty quickly with Mini-NDN. So a bunch of all the stuff that you can do with it. So another thing you could just also do is export this folder, and then this home folder like that. I've already terminated the Mini-NDN, but you could just export this folder. So, and then run the command from there as well. So basically, if you export it here, you would be able to run this. Now it will not be possible because the NFT is already killed, the Mini is killed, but you can basically export this home folder and then run all these. That command I stored from the command line from here too. So that's also another thing that you might be interested. So another experiment I wanted to show is Python sample. This is another experiment I wanted to show. This is a little bit complex than the previous one, but not that, but a little bit complex than the previous one. Just let's see how it looks like. We've already seen that in the slide, but just wanted to show again. So in this one, what we are trying to do is we have a 3-node topology, linear topology. We have already, we created topology from the script itself using this topo object, as I said previously in the in the slides. And then you start NFT and LSR with a bunch of log levels for NFTs, devolve, and info. And we advertise a prefix, and then we ping it, ping the server from the client. So basically, that's what it is doing. So it is using an NDN ping server and an NDN ping utility to do that. Yeah, this is another experiment. We just wanted to demonstrate the ping. Okay, let's see. The process is the same. We just need some time for NLSR to converge.
So is it possible to show us an output result of some emulation like ping from sample topology?
Yes, it is possible. So the thing is, like, we have, okay, let me show this to you. So all the experiments results get saved to your desired directory. For example, you can see, so you can configure a directory where you want to save your results. Like, for instance, this is a work directory. By default, we use temp Mini-NDN, and then this can be your result directory. You can set the result directory and work directory from the script. Like, for instance, you can set it work directory and then put whatever directory you want. And then all the results will be saved there. For instance, so for our case, C was the server, right? It was the ping server. So you can see the log from the NDN ping server, we saved it here. So if you go to NDN ping, then you would see this thing. Yeah, so basically all the experiment results that you can save those stuff. But as I said, like earlier, we don't do any processing. We don't do anything with those logs. Mini-NDN doesn't do anything, so you have to use some processing script to process the logs and then find the results that you're looking for. We have, this NFT logs. So we set debug log for this node, the node C, which was the NDN ping server. And you can see this bunch of nodes. So usually what I do in my experiment is that I would, if I'm trying to see the actual round trip delays or all those stuff, then I would see when the request went out from NFT and then when it was received back. So I would just compute this NFT log file. In other cases also, I would probably capture the packet if I want. We can use packet captures also with Mini-NDN and then you can also compute overhead and all this stuff. You can output the log of your program directly as it is done here. So this one, NDN ping server, if you see this one was, we redirected the output to this location. So yeah, here you see we have this output here. So your program can have your own logging mechanism, and then you can redirect those logs to this working directory or your result directory, and then you can process those. That's what we do usually. I also wanted to show this another example. This is a little bit complicated than the previous one in some sense. This is also a ping demo example. So this example is also basically doing the same thing. You have a prefix, and the ping server is run in one of the node. You create the topology, and this is another way of creating a route. You see this. You don't have. This one is not using NLSR. So we basically go through all the links and the nodes, and then we create the route if the link exists between the node. So we use this NFTC wrapper to create faces, and then we register the route for this particular prefix, so which is an example prefix here. So this is another way of, like, you don't have to use NLSR if you're doing this way. If you remember in the earlier example, what we did was we advertised this example prefix from NLSRs, but here this is how the routes are registered for this to this prefix. So you don't have to do that advertisement. And yeah, it's basically doing the same thing. One extra thing that it is doing here is you can fill a link, by setting a loss rate to 100%. So if you set the loss rate to 100%, you can. It's practically, it's like the link will not transfer any packet. So you can fill that link, and then you can. So this, what it is doing is, after filling, it is again doing the NDN ping, and then you would expect to get you'd expect not to get any data packet back, and then you are bringing the interfaces back again. So this kind of stuff also you can do, like filling link, filling a node or link, and then creating routes in a different way if you don't want to run your NLSR. So this is how you can slowly start writing a little bit more complicated scenarios. I just wanted to run this experiment to show you that it will show the exact intended behavior as it is in the script. So, and this will here you see it pretty quick because you don't need to wait for NLSR. Yeah, see, this first part is already done, and then you are putting 100% delay, 100% loss on one of the link, and then after that you would ping, you'd get timeout because the link cannot get the packet, and then so later on you'll again reset the loss rate. So yeah, kind of a common scenario in many of the experiments that we do. That's what I wanted to show here. Again, the results are saved temp Mini-NDN. This is a home folder for all these experiments. As I said, you could specify your own directory as well for the experiment results. Another experiment that I wanted to show is a Wi-Fi experiment. So this one is also pretty much similar with the experiment that we did, like the ping experiment that we did for the wired, wired scenario. So this is basically the experiment. So this is a simple topology, two-node topology with one access manager, and as I said, we just creating a face and the route for node A to ping another node, and the prefix that we're using is this example prefix. It was pretty much the same as the previous one. So there's no any extra stuff that makes it more complicated. It's pretty much coherent with how the experiments are written for the wired stuff. Wired, you just need the Wi-Fi object instead of Mini-NDN object. And rest of the thing is just a topology, which is a little bit differently configured or different than wired topology. And all the things are the same, basically the same. So let's run this experiment. So this is scheduling the ping from. So this one here, the scheduling thing is a little bit different than what we talked about scheduling in the previous one. So we in the ping we can actually schedule. So I think as Alex suggested, we can write a few of the extended APIs that we can extend this feature and make it more kind of a generic for other stuff as well. Yeah, so this is basically done. So your experiment succeeded. You can see the results of this experiment again here. By default, it will be on /temp/Mini-NDN. You have your these are from my previous experiments. Ignore that. So we have two stations that we used this time. So we can go inside the station and then see the ping data. So See, that's the ping data. So this experiment actually pings the client will ping the server 10 times. I think they both pings each other. I think in this one.
Maybe you can highlight so for the Wi-Fi experiment. So how is it emulating the access points, or what do you configure SSID? Is there such a thing in there in the first place?
Yes. So you're saying how is it configured?
I mean, like, where do you specify any of those things?
Okay. Yeah. So this one, you said this is one of the stations. So you can specify the SSID as well. I think there are some ways on how you can do that. Let me see. I had one slide, different slides.
I mean, so the two stations that you created, are they somehow connected to the same SSID?
Yeah, they're both connected to the same access point.
And how do you define the signal strength based on some kind of emulated distance, or how is it done?
If you look at the topology, then I think they are all specified here. So this is how you, I think the range of the access point, you can set this, and the position is, I think it takes the XYZ coordinate and then all this stuff. And there should be some more parameters that you can specify.
But can you go back and say?
Sure.
So you showed that the position for the access point, but for the stations, there is no positions, there's only a range. So what does it mean? I mean, relative to access point where those stations are located then? At 000?
I think, yeah, if you don't specify them, they will be located at 000, and you can, yes, that is true. I think, yeah, I'm a little bit not sure about that. I mean,
okay, so in that case, like station 1 should not be able to communicate if it's range 10.
Yeah, that is true. Yeah, that's why it was not able to. It was not able to. That's why it timed out, I think.
But even the other station not going to be able to communicate, because if 50-50-50 is Pythagoras theorem, it's far away, more than 50.
Yeah, it's more than 50. I had another slide that where you can have a different property of these stations, the IP address, channel mode, and for the access point, you can specify the SSIDs for the that for the virtual wireless network. Also, you can specify the channel mode and then all these properties. So there are many things in many properties for this. I haven't myself played with a lot of them, but I think people can feel free and then play with them and then try to configure this stuff as they need. I'm surprised that direct experiment didn't work because we don't have the range rightly configured. I think Alex is right.
I mean, the actual distance is 70 meters. So if you put the range as at least 75, then it may work for the station 2.
For the station, maybe a little bit more.
Yeah.
Maybe I'll just increase this one to. Let's try it once again. And it should be a little more. But once it timed out, and then again it been. Oh yeah, it worked now. This is for the previous one. It override the result file, I think. Yeah. So yeah, 90 seems like a 1500. Yeah, as I said, it should be more than 75. Let's see the another one as well. So in data. Tier 2 in data server. Yeah, the server is running here. This is a override from the previous experiment. So we basically need to clean that folder as well. And the server is running here, and then the client was able to ping it. And this is a very basic case for the Wi-Fi experiments. We can, I think, specify more complex scenario. I myself haven't tried that, but a lot of people in our lab have done experiments with those scenarios, like for instance, the specifying the mobility model and other stuff. Yeah, there's one more experiment here. There was one more experiment, a little bit more complicated. Yeah, this one has, if it is running with mobility model, it has a bunch of other configuration of other positions, and then by default, I think it uses some. Okay. Here we have to specify the Gauss Markov mobility model. Yeah, you can specify this stuff, and then also positions of your stations and your access point, and then run more complex experiments. That is for the Wi-Fi. Hopefully, after this tutorial, at least you'll be familiar with how to install and run some basic experiments. If you can reach up to that point, I think that will be very good progress, I would say. And then you can always go for and write more complicated experiments, not complicated, but more complex experiments. And then after, if you have any questions, you can just let us know. We have one more demo, which Varun will be demonstrating that. But before I go, I just wanted to say that you are welcome to try out Mini-NDN. Please let us know your feedback, suggestions, comments, and also feature requests. Since for us, it's been like we get a lot of email from people saying, asking us about some specific thing, and that gives us an idea of how what our software should look like. And based on that, we make a lot of changes, and also we make changes based on what we discover. We have a mailing list. This is also active. We try to answer as many questions as possible. Please consider contributing if you want. So this is our Redmine and Garrett. And as I said before, we have a lot more examples which you can see in the GitHub repository. So it has, how, like for example, as I said, like a running consumer producer example, more advanced examples, and also some other, like for example, traffic generator. If you're doing some traffic generator experiment, we use NDN traffic server for this one. You can look at this experiment and then write more. More. You can take this as a starting point and write your own experiments. So please take a look at these experiments, and also other stuff. Let us know your feedback.